Hello all, welcome back to our course on digital accessibility. And this week we will talk about certain verticals which we fleetingly mentioned in some of the earlier weeks, but we'll try to deep dive into some of them and try to understand what are the different opportunities and we'll try to understand what are the different opportunities and what are the different gaps with those special use cases. So, for example, we will talk about speech recognition and particularly for motor impairments. So, let us start with understanding what is motor impairment. So, motor impairments is something that affect your movement, your control. It can be permanent, temporary, or it can be progressive. It includes tremors, paralysis, muscle weakness, etc. It can directly impact how you interact with your keyboard or how you interact with touch sensitive digital interface. So then it is very important. So why some of the traditional interaction elements and approaches fail when people with special needs, particularly with impaired motor skills, have to interact with them? So use of pen or use of smaller buttons or use of mouse or use of keyboard, that requires fine motor control. And say for example, people who are experiencing paralysis or people who are experiencing cerebral palsy and motor affected limbs because of that, then it becomes very difficult for them to um, engage with small targets, and thus the error in interaction increases. Also, many a times some actions would require repeated actions, right? In some interfaces would require repeated actions. So for example, you may require a double click on something which is said to be only so much microseconds apart, then it is considered as a double click, right? So then it may also be causing fatigue, or there may be other interfaces which may be requiring you to press that button for 15 seconds and hold it, then it also may be causing fatigue. Then there may be time based interactions which can be difficult, so that you have to complete certain actions within a certain time window, and then that becomes a little problematic for people who are facing motor difficulties. So in this case, of course, our traditional approach of pressing like visual cues, and then there is call to action, and you're pressing buttons, or you are engaging with a mouse on the screen, that is of course there. But then how we can enable speech as an alternative input, right? So speech enables hands-free interaction, and largely we are now seeing a lot of speech-based interaction with NLP, kind of gaining a lot of momentum. NLP research is gaining a lot of momentum with the, so NLP stands for natural language processing. It is enabled by AI and ML, and there are models which are now able to recognize the semantic meaning and even different accents, voice of children, everything, and recognize and understand what the person is saying, and then actually enable hands-free interaction and just through speech. I'm sure all of you might have seen Alexa, or you might have, pressed that mic button on your TV remote and for it to search a video or a movie on your smart TV. So it does reduce physical effort. It does use the natural human ability to just speak and tell your needs, right? It complements other input methods also, because it adds an alternative of not just interacting with the visual elements but also being able to tell it. So also people who do not have any visual motor impairment may just don't want to press so many alphabets in order to search on a television. So that kind of increases or enhances the experience for them. So what is speech recognition? So I did speak about NLP, but let's try to understand how it really works. So speech recognition is a technology that converts spoken language to text or commands. So it is used for dictation, control, and navigation. It relies on audio input and language models widely available on consumer devices nowadays. So all of these agents which you are able to work with, is whether it is okay Google or hey Siri, I'm sure you all have interacted with it, Alexa, all of them are using speech recognition models which employ NLP. So there are different types of speech based interaction. So one can be speech to text, so it can be dictation. So the model is able to directly convert your speech into text, so you are able to type using speech. And I think we are on a day-to-day basis, if we are interacting with a messaging app like WhatsApp or even messaging, now it is very easily possible to hold the mic and just ask it to type when you are dictating. Or if you are writing a Word document, you can ask it to press the dictate button on your Word document, and it will be able to most of the time convert your speech to text in real time. So this technology has um, kind of matured a lot over the past decade, and now it is very much ingrained in a lot of day-to-day interactions that we are having with consumer products. Then there can be voice commands. So voice commands, again, we are saying that, okay, hey Siri, call XYZ on my mobile phone. Then Siri is able to make the call, or you say, okay Google, find directions to IIIT Delhi, then it is directing you to a Google map. So then there can be conversational agents which are generation GPT based, or generative AI based. So they kind of talk to you as if a human is talking, and they are able to both interact and take commands. Then there is voice control navigation. So you can ask the car to take a right or a left, or you can move the cursor using your voice, go to the next item or something like that, right? That is voice control navigation. So some of the common examples, as I mentioned, right, like, so hey Siri is again developed by Apple. Hey Cortana by Windows, and Alexa, Amazon. Okay Google is Google's. Hey Bixby is something also which is there. So you can, through your voice command, you're now able to give commands like open a browser, turn off alarm, save a document, turn on music, right? And then AI is able to interpret all of that and do the required things on your mobile phone. So it is also not just an enabler for people who are facing difficulty with motor movements, but it is also allowing you to reduce your own screen time for a bit. So how speech recognition technologies work? So once you speak into the microphone, microphone catches it in an analog format. So then first step is then analog to digital conversion. Then there is sampling and analysis for digitized voice data. Then algorithms convert those digitized voice to text. For a command, conversion to required output, as text or links to CRM. So either it is text or it is a customer relationship management systems and other apps. So once it is converted to text, you can use it according to your need. So voice access for motor impairments, it allows full device control using voice. If I say take photo, I don't need hands to actually click. It can just take a photo of me. Users can tap, scroll, type, edit, etc. Everything using speech. Reduces dependency on touch to a very, very big extent, and enables independent device use. So in terms of design benefits, so it, as we said, enables hands-free operation, reduces physical strain, increases productivity, because many a times you don't need to type, you're just voicing out your ideas, and it is in real time getting converted into text document. Allows for greater independence. So what are the different day-to-day life gaps which a speech recognition is now able to fill? Is writing messages and emails, browsing the web, controlling smart devices, filling out forms and applications, scheduling, reminders, calendar tasks, hand-free media, entertainment control. But there's still some challenges in speech recognition. So one may be speech variability and accent. So if people are having lisps and stutters, then it is a little bit difficult for the speech recognition model still to understand those speeches. If the accent is very heavy and if there are not enough data for that kind of an accent, probably they may not be able to understand those accents. If there is a lot of background noise, then the speech recognition device may not be able to understand and kind of bifurcate your voice against the background noise. Then there may be some speech impairments as well, so because of which the system may not be able to understand what you are saying. Error correction can be difficult. So if, for example, you are doing a dictate function on your document, if there is an error, just by voice it will not tell you, um, by default it will not tell you that there is some error or there is some spelling mistake or there's some grammatical mistake, and then and that even telling the system to go back and make that correction in that line, etc., becomes very difficult. So another thing, when we are designing for a multimodal system and we are talking about integrating speech recognition, we also have to be very sensitive about the cognitive load considerations, right? So remembering commands can be very demanding for some individuals. Continuous speech may be tiring also. Feedback must be clear and timely. So if there is a feedback that I am not able to understand what you mentioned right now or what you said right now, then it should be timely, in a timely fashion. It should not happen after 5 minutes, right? Then design should reduce mental effort. How we can use speech recognition in education? So voice typing for assignments, so as we were saying that it is like a dictate only, and hands-free navigation of learning platforms. So you can just by voice command you can do choose your language. You can go to click start dictation, you can go to click allow, all of those things. Support students with motor disabilities, enables participation. How it can be useful in workplaces? So document creation is, of course, everyone would be happy to, not typing long documents but just dictate them. Typing email and communication using speech recognition software control, remote work accessibility, and during meetings and official communication, if there is a note taker which is also kind of transcribing the meeting in the real time, it is able to do that. And it is also a quick fix, and it is able to generate meeting summaries, or it is able to generate minutes of the meeting by itself. Then it's just faster and more efficient. So, but however, not all users benefit equally, and speech impairments may limit the use of speech recognition software. So, it must be optional, not mandatory. So, any input system, speech recognition or speech based input or navigation is a kind of an input device, or right, it's kind of a replacement for an input device. But we have spoken about this earlier as well, that anything which, whenever we are talking about accessibility, we have to offer choices, right? So of course we cannot wholly and solely rely on speech recognition as the sole input methodology. So we have to ensure that it allows for GUI based input, as well as your keyboard based navigation, as well as other ways of input. So it works best with multimodal support. So in multimodal interaction, we talk about combining speech with touch or keyboard. This allows for fallback options. So if I want to do some error correction, I can use other methods to do. But largely, if I am using speech recognition for higher productivity, for motor impairments, then it's great. But if there is some error correction, I can have fallback options. If there is an assistance which is available to help me, they can also interact with the same system. So it basically improves robustness, and it supports diversity, it supports diverse users. So for example, a tactile graphic with a voice for blind users is a good example of a multimodal interaction. Some common guidelines for voice interfaces: so use simple natural language commands, provide clear prompts, avoid reliance on memory, don't make the system look for specific keywords in order to trigger navigation or trigger action. Uh, so this is something which is called natural language processing and semantic modeling. So people might be using a number of kinds of sentences to do the same, to give the same command. But if they're asking, if the system makes you want to remember multiple commands, and only with that particular word the action gets triggered, then it becomes very difficult for people to remember and do that. Offer alternatives, so user-centered design practices should be employed. Some of the common design mistakes that happen is that assuming that speech works for everyone. It is definitely a good alternative, but forcing only voice interaction can result in poor feedback on errors. It can lead to ignoring accents and diversity. It may have latency issues in voice feedback as well. So how we can ensure error handling in voice interfaces? So clear feedback when error occurs. So the system should be able to clearly give a feedback to the user that this command was not interpreted properly, please say it again, something like that. There should be easy correction mechanisms available. Avoid long command sequences. So just maybe a phrase, search for baby shark videos, or you just hey Alexa, tell me about Delhi's weather today. Try to keep it short. Support undo and confirmation. So it should be able to, I should be able to quickly tell the system that, oh, I'm sorry, I don't want to know about the weather, but rather I would like to know about the pollution levels in Delhi. So probably that is also something. So quick responsive models are needed, and that may require some more research and development in the domain. Then there may be some privacy and ethical concerns as well. So one of the primary being that voice data is sensitive. So always listening voice systems can unintentionally capture private conversations as well, raising concerns about privacy and security. So if they are always on, looking out for, listening to all of the conversation, looking for your keyword of Siri or Alexa, that means they're always listening, and then that actually brings on privacy concerns. But user must have control over that data, and transparency is essential. WCAG principles also apply to voice interfaces, and WCAG 3.0 is largely talking about this in more detail. You can visit the website and dig deeper into what the WCAG principles say about voice interfaces and accessibility. Then there can be environmental constraints. So noisy environments reduce accuracy, public spaces limit the voice use. Social comfort also varies, right? So if I'm in someone else's house, I may not want to tell if I'm setting up an alarm for 6 a.m. in the morning or 10 a.m. in the morning. So context aware design is very important. Assistive technology integration, so works with screen readers. Make sure that your voice interaction systems, they work well with screen readers. In the previous week, we have spoken at length about visual navigation and screen reader, and how well they should be connected to each other, and how we can do the evaluations, etc. Make sure that your voice systems work well with the screen readers as well, because screen reader is also a voice interface by its very nature. So the voice interface should not interfere with the screen reader voice navigation. So one has to make sure that that does not happen. Allows for switching devices. It should be able to complement other assistive technologies and should be a part of assistive technology ecosystem. So in future, of course, there's still a lot of gaps that need to be worked upon. So first is definitely that the speech models need to be improved in order to capture other aspects of visual of speech impairment itself. So lisps and stutters and or accents, etc. Then there is personalized voice recognition training, which the models can be trained on. So once the model is trained on your voice, they are able to recognize missing words and bridge the sentence to form a semantic meaning as well. Context aware systems need to be developed that make are able to understand what is the situation and kind of draw a semantic meaning from smaller commands as well. They don't need a lot of context or a lot of descriptions many a time. So, and then better support for diverse speech. What is the role of designers and developers in this regard? So make sure that you include speech as an option, largely because a lot of speech to text and text to speech models are available for free. Make sure you integrate them in your products. Try to make them accessible. Using voice and speech recognition as one of the alternative input and output devices. Test with real users, design for flexible use, and iterate based on feedback. So one of the key takeaways from this session is that speech recognition enables access when touch fails for blind users, or when visual interface also is failing in some cases, right? So it's a powerful tool for motor impairments, and it's also very powerful for persons who are blind. It has limitations and challenges, but if used in a unimodal system, but it is best leveraged when it is part of a multimodal design, because you have fallback options, you have better feedback systems, you have better correction systems which are multimodal in nature. So do try to integrate speech recognition and STT and TTS models in your design in order to make them multimodal to begin with. And do test with WCAG and other benchmarking standards in order to make them accessible for persons who have motor impairments. Thank you for listening to us in this session. I will see you in the next session.